Okay, this is going to be the Unit 3 sample test for pre-calculus for 2019-2020. First part will be calculator, second part will be no calculator. So this first problem where it says show the third differences between the f of x constants. So what I'm going to do is 844.8 minus 550.6. That result will be 294.2. Okay. Then I do this result here, the subtraction of those, 550.6 minus 334.4. Oops. Is 216.2. Then I do these. Okay, so I'm subtracting all those. 334.2. 334.4, sorry. Minus 184.2 is 150.2. Then I do these, which is 184.2 minus, I guess 88, 96.2. Then I do these, okay, which is 88 minus 33.8, which is 54.2. And then I do these, okay, 33.8 minus 9.6, 24.2. Okay, so that's the first level. All right, as you can see, all the differences are different. So then what I'm going to do is I'm now going to do these. Okay, all right, so I go 294.2 minus 216.2. I get 78. I do 216.2 minus 150.2. I get 66. I do 150.2 minus 96.2. I get 54. Then I do 96.2 minus 54.2. I get 42. And then I do 54.2 minus 24.2. And I get 30. Okay? So as you can see, first level, different. Second level, different. Then if I subtract these, okay, so we're just overlapping, just like the other ones. Okay? I'll go 78 minus 66, 12. Okay? 66 minus 54, 12. Okay? 54 minus 42, 12. 42 minus 30, 12. Okay, so that's level 3. So that shows the third differences. It's a cube. So since it's a cube, when I go into menu and stat, okay, I can put in my values 2, 3, 4, 5, 6, 7, 8. Okay, and then the y value is 9.6, 33.8, 88, come on calculator, 88, 184.2, 334.4, 550.6, 844.8. Okay, then I can do calc, reg, and then since it's a cube, I can pick that. Okay, if you move down, it will show you how they want you to write the equation. So the a is about 2, so 2x cubed minus 3x squared. Okay, because that's what that is, plus 1.1 or 1.2 x plus 3.2. That would be this actually would be the answer for this problem. Okay? All right, the rest of them are going to go a lot quicker than that, but that's how you start that. Okay, draw the complete graph in the standard window. So what I would do is I'd go to menu and graph, type this in, x cubed minus 5x squared plus 3x plus 9, draw it. You get the standard window. Standard windows if you hit F3 twice and draw. Okay, so I want to find these things. I'll do G-solve root, so it crosses at -1 and it touches at 3. Okay, so x equals -1 and x equals 3. Okay, all right, -1, 3, and this one it touches there. Okay, all right. I'll get the y-intercept. G-solve y-intercept. Y-intercept would be 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So the graph looks like this. Okay. To get the max, I do G-solve max, which is 9.48. Okay, so that's like right here. That's the top. Okay, and then the minimum will be 30. Okay, which will be right there. How many real zeros does this have? Well, this has 2 terms. Okay, which means that the degree would be 3. Okay, all right, and the number of real zeros, this counts for 1, 1, and 1, so this would be 3 real zeros. Okay, what could be a factor? Well, that crosses at 1, 2, -3. This crosses at 1. Okay, so the factors would have to be like x plus 1. All right, x minus 1, basically x minus 1 twice because it's squared. So the only opportunity, the only one there is d. All right, state the intervals where it's increasing. Okay, this one is, we've done these before, so there's a lot of carryover. Plus 5x squared. Minus 9, draw. Okay, the big thing I want to worry about is the minimums and maximums. The max there is 1.6, -4.3. So I'm going to make a rough sketch. Okay, that's a terrible rough sketch. Hold on. Okay, what did I set up here? It's going to look something like this here, here, here. Okay. So that's 1.6, -4.3. Okay, and G-solve minimum, 0, -9. Okay, if I'm doing arrows, that's a left arrow going up, so negative, infinity, positive. This is a right arrow going down. When I do increasing, decreasing, all I care about are these. Okay, so I go from the left, this would be the decrease, this here would be the increase, this there would be the decrease. So the only one increasing, so that's from 0 to 1.6, which would be that one. Okay? Let me erase some of this stuff here so I can see. All right. Okay? It says use synthetic division to divide x plus 3 and get a remainder of -6. According to the remainder theorem, which of the following is true? Well, what that is going to be is I would be substituting in that. Okay, so what it basically means is if I evaluate this, whatever the result is, okay, all right, that's going to be that. So that's going to be letter B. Okay, so when you use synthetic division, if you do that and you get a remainder of -6, that means that if you were to evaluate that function, that's what you would get. The Descartes rule assigns positive negatives. The way we do the negative ones is we substitute a negative in for x. It's like the odd test. Okay, so this will change this sign, so now it will be negative x to the 5th. Evens keep the sign. Odds change the sign. Another odd changes the sign. And that's just going to be 7. So if I count this up, that's 1 change, that's another change, That's another change. Okay, so I got 3 or, all right, if you subtract 3 and 2, you get 1. So the answer is right there. Okay, 9. Now we're in the no calculator part. Circle the possible degree. Well, if I count the turns, 1, 2, 3, 4, 5, 6. So I got 6 turns. Okay, so I got 6 turns plus 1 will give me the degree, so my degree is 7. Okay, this counts for 1, this counts for 2, this counts for 1, this counts for 1. Okay, so if I total that up there, that's 3, that's 5. 5 zeros, 5 real zeros. Well, these two have to add up to be this, so that has to be 2. Okay, circle the end behavior. What I'm looking for is the biggest exponent. Okay, and so we're tying that back into which one of these pictures is this tied to. Well, this is an even, so these are evens. Well, this is even, odd, positive, negative. Okay, so this is even, but since it's negative, it would be here. So if I follow those end behaviors, okay, that's negative infinity, negative, positive, negative. Okay, so the same thing applies to the limits. So I'm looking for one of those that both has this, which will be that answer there. Oh, there we go. Okay, same deal. All right, this would be this one. So I would be at this kind of one. So that's negative infinity, negative. And that's positive, positive. Okay. All right, so the limit is x approaches infinity is positive. So I'm looking for positive. So it's either one of these two. Okay, so as it approaches positive, that's not that one. As it approaches positive, it's positive. It's negative, so that's why the answer is B. Okay, write an equation of the polynomial factored form where P of 0 is negative 72. Okay, all right, so what I would have here, if that's at x plus 1, okay, from that, x minus 3 squared. So I would go ahead and multiply that. Okay, just to save us some time, that's going to be x squared minus 6x plus 9. And then I multiply by x plus 1. Okay, so it's x cubed minus 6x squared plus 9x plus 1x minus 6x plus 9. So what this polynomial is here, I'm going to write that up here, would be x cubed. Okay. I did something wrong here. This should be 1x squared. Okay, so I got negative 5x squared. Okay. The 9 and the negative 6, if that's a negative here, 9 and negative 6 would be 3. Okay, and then that would just be positive 9. Okay, well, if I evaluated this, I put in 0. Okay, if I put in 0 for those, what would end up happening is I would have a result of 9. Okay, so I need it to be negative 72. So the only way that's going to happen is if that were to have the negative with it. Okay, negative 81. So in factored form, what this would look like is this would be x. So these would combine to get you the negative 72. So I got x plus 1, x minus 3 squared, minus 81. Okay, that would be my function with the f of x. Okay, so that's my function there. Okay. Let me do this one while I'm already here. State the possible zeros. So the idea is the factors of this number, factors of 3 are 1 and 3. Factors of 4 go down here. That's your leading one, goes down underneath. And then I divide these. 1 divided by 1 would be 1. 3 divided by 1 would be 3. 1 divided by 2 would be a half. 3 divided by 2 would be 3 halves. Okay, 1 divided by 4 would be a fourth. And then 3 divided by 4 would be 3/4. So that's the answer to 16. Use synthetic substitution to find P of 3. So the idea is I take 3, I'm going to put that into here. 0 would be 2. 2 times 3 would be 6. Negative 8 plus 6 would be negative 2. Negative 2 times 6 would be negative 6. Okay. 10 minus 6 would be 4. 4 times 3 would be 12. 14 plus 12 would be 26. So what P of 3 equals is it equals 26, whatever the remainder is. Okay? That's like from the question we had earlier. Okay, let's go to these. Okay, sketch this. So what I gotta know, okay, that's a degree of 2, a degree of 3, and a degree of 1. So it's a total degree of 6. This is positive, so my end behaviors are gonna look like that. Okay? This solution here would be a touch here at 0. This solution here would be a touch at negative 2. This solution here would be a touch at 4. Make sure you guys can see that. Yep, okay, great. Okay, so at negative 2, all right, this is going to go through, and when you get to here, it's going to almost make that cube look. At the squared, or at the x, it's going to turn, and then this one will just shoot on through to that arrow. Okay, so you make the little cube deal, all right, like that. Write the equation of the 11th degree. Okay, so what this would count for is 1, 4, 3, 2, and 1. Let's see if that adds up to 11. 5, 8, 10, 11. Fantastic. Okay, so I got my function. This would be 1, 2, 3, 4, 5, 6. So x plus 6. This is x minus, or x plus 3 to the 4th. This is x plus 1 cubed. This is x minus 2 squared. And this is 1, 2, 3, 4, 5. This is x minus 5. Okay? All right, now, since this is a negative polynomial, I got to put a negative there because it's a negative odd. Okay? I think I'm going to 16 is next, or 17. All right? State the intervals where the function is increasing. Okay? All right? This is negative, positive. This is positive, negative. Okay? All right, 2, 0. All right, that's like 0.5, negative 100. That's like negative 3, 200. Okay, that's like negative 5, 0. Okay, so I trace this way. That's the decrease, increase, decrease, increase, decrease. And they want the various intervals. So for increasing, let's start with that. And all I care about are the x's. Negative 5 to negative 3. All right. 0.5 to 2 would be the increases. The decreases are from negative infinity to negative 5, from negative 3 to 0.5. Okay. From 2 to infinity. Okay. Factor over the set of complex numbers. Okay. Okay. This is a U substitution deal. Or actually, what we have to do here is figure out which one of these solutions will go in. So if I look at my rational root theorem, okay, factors of 27 are 1, 3, 9, and 27. Factors of 1 are just 1. So it's pretty much all of these. Okay? All right? We're probably going to have some combination of 3 and 9 to get 27. So I'm going to go ahead and try, let's say we'll try 3 with synthetic division. 1, 3, 4. All right, as you can see, I'm way over. It's like 100 and something, 117. Well, it's way over, so it can't be 3. Let's try negative 3. So 1. That's negative 3. That's negative 2. That's 6. That's 33. That's still negative 99. So we know negative 3 is no good. Okay. All right. Let's try 1. All right, see if that, or -1, let's try that one. 1, 1, 27, 27, 0, 1 and 1 is that, it's going to be -1, it's going to be 0, it's going to be 0, 27, -27, 0. Fantastic. So I found one that worked. Now, the result out of this is x cubed, okay, basically plus 27x. Okay, because there's no x squared term, there's just an x term, there's no number. Okay, all right, actually, yeah, so that went x cubed, x, oh, I apologize, I'm doing this wrong. Go back and, I made a mistake here. I left off a term in the synthetic. So if you're doing this, I apologize, I left off a term in the synthetic. Let's try that -1 again, see if that works. 1, 1, 0, 27, 27. Let's see if that works. So that's 1, that's -1, which would be 0, 0, all right, 0. I think that ends up still working, all right, that would be 27. -27. Okay, so what that would be is this is now x cubed, this is now x squared, this is x, this is my number. So what I got here is I got x cubed plus 27. Okay, now that's terrible. All right. So if I factor this, we worked on this in class. That would be x plus 3. These next three parts, this is x squared. 3 times this, it's got to be 9. Okay. To figure out these, I multiply, that's 3x, and I change the sign. Okay. So these would be my factors. My factors would have been x plus 1, x plus 3, x squared minus 3x plus 9. Okay. So my solutions out of that, we got, we're -1, we're -3. Now, I have to use the quadratic formula for that, okay? So if I apply the quadratic formula, that's 3 plus or minus -3 squared minus 4 times 1 times 9, all over 2 times 1, okay? Well, inside that, this would be 9 minus 36. Okay, which would be -27, okay, all right. What ends up happening out of that is 27 will factor to 3 plus or minus 3i square root of 2 over 2, okay. That would be my other solution, okay. So this would be my solution into that, all right. So 9 minus that, if you need to factor, you need to, that'd be 3 and 9, 3 and 3, okay, that's the perfect one. Sorry, that should be a 3 on the inside. Okay, so that's where the I comes from, the negative square root, and that's where you get that. So sorry about the synthetic. It ended up being similar. Okay, this one I can actually just move the 81 over, so it's m to the 4th minus 81 equals 0. Now, what I would do with this, okay, it's pretty simple. This is like a perfect, we can do a u substitution where u is equal to m squared. So the idea is this is u squared minus 81. Well, that becomes a simple factor of u minus 9, u plus 9. Okay? And then I put the m back in, so m squared minus 9 and m squared plus 9 ends up being your factors. Okay? Well, if I go to solve that, okay, m squared minus 9 equals 0. I add 9, m squared equals 9. Square root plus or minus, so m equals plus or minus 3. This one, set equal to 0. Subtract 9, m squared equals -9. Square root of that, plus or minus, is m is plus or minus 3i. Okay? So that's how you get that one. Okay? 20. Descartes sign rule. Okay, all right. To do the positive ones, okay, all right. Here would be the idea is how many sign changes? I got 1 sign change, 2 sign change, so that's 2 or 0. Okay, all right. When I do the negative ones, I got to substitute in. Okay, so what's going to happen there, and I'll erase this in a second, that will stay x to the 4th, that will change. This, because it's squared, will stay the same. Okay, and this will change. Okay, all right, and then this will stay the same. Okay, so if I look at the number of sign changes, that goes from here's 1, here's 1, here's 2, okay, so there's 2, so 2 or 0, okay. So how do you figure out the non-real? Okay, it could be a number of things. If they're both 0, that would be 4, okay. If these are 2 and 0, that would leave you 2 left over, or if they both are 2, then that has to be 0. So there's all those combinations, okay. All right, let me erase this. I think I missed a problem at the beginning. I have to go back and do. Okay. State the possible zeros of g of x. Okay. All right. So the way I would do that is that's going to be 18. The factors of 18, which would be 1, 2, 3, 6, and 9, and 18, all divided by the factors of that 1. So all those would just be that. Okay, is this a factor? The way we would justify that is I would put -2, so I got 1, 1, -11, -9, and 18. Okay, so that's 1, that would be -2, 1 minus 2 would be -1, -1 times -2 would be 2, -11 plus 2 would be -9, -9 times that would be 18. -9 plus 18 would be 9. 9 times that is -18. Okay? Alright, so what I got is I got 0. Okay? Alright, so then what I want to do is I want to test, so my result, okay, my result for that would be x cubed, okay, minus 1x squared minus 9x plus 9. Okay? Alright, so I already know, alright, I can do the rational root theorem for that now. Okay? I know that the only factors out of that have to be 1 plus or minus 3 plus or minus 9. So those are the only ones I have to try left. Well, all right, so I know that one of the factors will be x plus 2. Okay, all right, so I can just use synthetic division to figure out which ones are remaining. Okay, so let's say I wanted to try, I don't know, let's say I wanted to try 1. Okay, so 1, -1, -9, 9. So it's 1. That would be 1 times 1 would be 1, that would be 0, 0, -9, -9, which would be 0, okay? So what's going to be, so my other factor there, all right, would be x minus 1, okay? I've got x squared and just minus 1 there, all right? Oh, whoops, that's not right. That should be -9, sorry. So that would be my other factor here. Well, that's pretty simple. That would factor to x plus 3 and x minus 3. Okay? So what I got here are my factors. I would have x plus 2, x minus 1, x plus 3, x minus 3. So those would be my factors. Okay? All right? And then let me erase some of this. Okay, these last two questions will not be asked actually on this, so we don't need to worry about 24 or 25. This will not be on your assessment. Okay, I think I skipped a problem back here. I want to go back and look. I got those. I think it's on the first page. Okay, maybe I didn't skip one. Let's double check. Yeah, I think I got all those. Yep. Yep, those last two will not be on there. Yep, and that's it. So I apologize about that one question. I just missed up on the synthetic. Make sure you have a lot of paper to do the work on, because some of those can be sort of tedious to try, but the calculations aren't overly hard.